Okay, so let's use this short video to explain how you would solve a question like this on LogicGate. In this, but let's read through the question first. This question you're asked to derive the Boolean expression. Okay, derive the Boolean expression of the circuit diagram shown below. Okay, so you are given a circuit diagram, you are asked to derive the Boolean expression. Before we try to solve this thing, let's look at the logic circuit, and structurally let's identify what are the inputs. Okay, these are the inputs. Okay, and how many outputs are there? There's only one output. Okay, so if there's only one output, you would expect your answer to be just k equals to what? Okay, sometimes you may get a circuit diagram that has got two outputs. Then you will be expected to derive two expressions. Okay, so let's go ahead and derive this expression. The method that you would use to solve this type of problem is very simple. You can imagine yourself to solve this, you imagine yourself walking through a maze, M-A-Z-E, a maze. Imagine you're a little mouse and you kind of jump over certain obstacle course and you transform yourself along the way. So there are three little mouses here, mice here, and then I want you to see how you could, one little mouse would transform itself to another form and so on, going through this the obstacle course. In this case, the obstacle course is really the logic gates. Okay, so let's start. So you got A. So A going through this logic gate. First of all, you must identify that is a inverter. Is basically providing a reverse logic. If it is A, it will become A bar. Okay. So essentially, it's trying to produce a reverse logic of what is in its input. So this is A. So going through this so-called obstacle course, this logic gate, it will become A bar. Okay, and let's try to transform yourself now at this point. Now at this point, this is a AND gate. Okay, bear in mind, we see, look at the diagram like this, something that is straight here and you have a curve here, that is a AND gate. AND gate. Okay, if you go through an AND gate, then you would transform yourself. There's two inputs, A bar and B, so you would represent it this way: A bar AND with B. Okay, kind of A bar dot B. We normally don't draw the dot. Just like in multiplication, we don't really necessarily need to put the dot when you say x times y. You just put xy without necessarily putting the dot. Okay, so this is part of after transforming yourself through the AND gate. Now let's go ahead and transform ourselves again through this thing, through this gate. But before you could transform yourself, you realize that, oh no, you could not, because there is nothing here in the input. So you could not do the so-called transformation process, and you must trace back what is here, what is the inputs coming from here. So you trace back. Okay, I don't have the answer. You need to trace all the way back. Oh, it is coming from C. Okay, so you ask yourself, C going through a inverter, what do you get? Yes, you get a C bar. Okay, C, not C. Let's call it C bar. Okay, as we have. Okay, and I'm just copying the symbol here at this point. So let's transform ourselves. Okay, but some students may find this this symbol to be a bit threatening. Oh, I don't understand this. I could understand this. This is OR gate, but what do you mean by OR gate with a bubble here? Okay, so this is actually a NOR gate, but for those students who are not comfortable dealing with a NOR gate, I would suggest that you just simply redraw this diagram. And what you could do is this. Take away the bubble here. Instead of drawing a bubble, okay, let's just ignore there is nothing here. But instead of drawing a bubble, you draw a inverter. That's the meaning of a bubble in front of a gate. When you see, every time you see a bubble in front of a gate, if you are not comfortable with it, by all means do yourself a favor, erase away the bubble and then draw an inverter in front of it. Then it makes it much easier for you to go through that transformation process. Okay, so let's with all the inputs ready here, we are ready to do the transformation again. So let's see. So it is an OR gate. Okay, it is an OR gate. It's OR gate. So OR gate is represented by the mathematical symbol plus. Okay, where you put in whatever that is in the at the inputs. So there's two sets of input. This is the first set of input, A bar B. This is the next set of input. So let's just put it down as it is A bar B. Okay, and the next set of input is C bar. So after going through the OR gate, this is what you've got. Okay, but that's not the end, because remember we kind of erase away the bubble. So you need to further transform the cell going through from the output of the OR gate to the inverter. What do you get? So simple. Okay, whatever going through an inverter, whatever you got through an inverter, all that you need to do is to invert the entire thing. Bear in mind, you have to invert the entire thing. So let me draw that here. Whatever you've got, this is what you got. Okay, just invert the entire thing. Make sure you invert the entire thing. And so what is that entire thing? Okay, the entire thing is A bar B plus C bar. That is the entire thing. Okay, but of course in exam we normally don't in the written script we don't express it that way. We don't draw a big circle around it. So what is a good better way to present the answer is by means of using brackets. Okay, you just use bracket to indicate to the examiner, yeah, you meant inverting the entire thing. Okay, I want to emphasize the fact at this juncture, just a sidetrack a bit, this is not the same, it's not equals to, for example, this expression, which a lot of students has a tendency to assume is the same. Okay, it's not the same as inverting the individual inputs, the inputs individually. Again, what I want to say is inverting something in totality, okay, is not the same as inverting the inputs individually. Okay, this is not the same. Okay, it is not the same. Just know for a fact it is not the same, and so don't assume it is the same. Okay, do yourself a favor, make sure you don't assume it is the same. So let's erase this not the same thing. Erase it from the picture. Okay, this is the answer at this point of time. Okay, this is the answer for this input at this point in time. Now we are ready to derive what is the answer for K. Oh, no, we are not quite ready. Or even though we got one of the input, we still do not have got the other set of input. So we are not ready to transform ourselves. So let's trace back what do we need. Oh, we don't have anything coming from here. We need to trace back what comes before this OR gate. So let's trace back this first input here. Let's trace back. It is from A. Okay, so since it's from A, so let's just copy down. Just remind yourself this is A. And what okay, can transform it? No, not yet. Now you still need to ask yourself what is the input here. So let's trace back. Okay, you see a curvy line here. This is just to indicate to you, hey, A and C are not the same, are two distinct lines. They are not shorted together. They are not connected at all. Definitely you don't cross connect two inputs together. They must be two distinct lines. So the curvy line is just to indicate that. Okay, so you just trace back. Okay, so there's your C. So just simply draw a C here. Okay, yes, well, the input has arrived at the OR gate. So let's transform ourselves again. Again, remind yourself this is the OR gate. So going through that, going through this transformation process to determine A and C is going to be becoming A plus C. Okay, now let's happily go through, bring that forward. No change, is a physical line. So I'm just simply copying my A plus C upwards for clarity's sake. Okay, so you got two sets of input now. Now you're ready to transform. In fact, upon transformation, this is exactly what you're looking for. So so you have two inputs. This is the AND gate, right? It's an AND gate. So it means to say that the output here will be something ANDed with something. Okay, sometimes normally we don't really need to put the dot here. It's standard convention. If you just put two brackets together, it means something ANDed with something. AND with something. Okay, so so that's the answer. K equals to something ANDed with something. Okay, let's just put it properly in a diagram. So this is my K. Let's work out. K equals to something AND with something. What is that something? The something here is one of the inputs here, okay, which is this entire thing here, okay, which is A bar B plus C bar, this entire thing here, okay, to be ANDed with the other inputs here, which is A plus C. A plus C. Okay, and ladies and gentlemen, that is the answer. Okay, how simple it is, right? Just going through the little obstacle, transforming yourself into something else, not, plus, multiplication, XOR, whatever that you learn in Logic Gates, and then just leave your expression as it is, as the final output. Simple as that. Okay, thank you. I hope you enjoyed this video and I hope you learned something from it. Thank you very much.